AM5 has launched out the door, and I've got a review of the ROG Crosshair X670E Hero. It's an extreme X670 motherboard, and it's got so many features, so it gets its own video. Plus also, you know, SEO, and if you buy it, you might use the link, and I might get the affiliate click because, you know, you were considering this motherboard, and I can tell you the good features and the bad features and everything else. I don't know, we'll see. So AM5 is the new AMD platform, and it's got a lot of really interesting features. One of the big ones is that it's kind of a dual chipset design. A lot of people, the last generation, the X570, they didn't like the chipsets having a fan. Well, AMD has sort of spread the complication out to two chips, and this motherboard uses both chips. X670E Extreme, that means PCI Express 5. We have two physical X16 slots that are for GPUs or other PCI Express 5 peripherals that are wired directly into the CPU. There's also two M.2 slots that are also PCI Express 5 wired directly into the CPU. Our X670 chipset, they're daisy-chained. The first X670 chipset is connected to the CPU via PCI Express 4.0x4 interface, and then there's another one connecting that way. Now, this motherboard layout, it leaves me scratching my head a little bit in terms of connectivity. So we have the two PCI Express 5.0 M.2. That's perfect. Asus has done an incredible job. That's amazing. And then we have two more M.2 that are PCI Express 4.0. Those connect through the chipset. However, our total amount of bandwidth all the way back to the CPU is only PCI Express 4.0x4. So it wouldn't make sense to use something like a RAID 0 or a RAID 10 or a RAID 5 of all four of these, because those two M.2, if they're in use at the same time, they're going to be competing with one another for bandwidth. So Asus has included this nifty little thing. It's mostly heatsink. It is a substantial piece of kit. This is a PCI Express 5.0 to M.2 adapter. It takes up the by 8 slot. It's meant to be used in the by 8 slot that's near the bottom of the motherboard, but it's only by 4 electrical. Like, this board could have two M.2 slots. You could maybe do bifurcation, but it doesn't support that. You only get the single M.2. So this giant card with this giant heatsink is to add a third PCI Express 5.0 M.2, which would maybe be pretty cool if you were gonna rock, you know, a RAID 5 configuration with M.2. I still really recommend the operating system handle any kind of RAID array that you might want to be doing with NVMe, as opposed to the AMD software driver RAID, because I've done a deep dive on that, and it's gotten some attention in this generation, but again, not really super high on my list of recommendations. RAID 1 for mirroring and data redundancy, that is the best one, but you got two onboard PCI Express 5.0 M.2. You don't need that. One of the coolest RGB features of this thing is the Polymo lighting thing. So there's a Polymo lighting. It's like a little display thing, sort of, kinda, that's on the rear I/O of the motherboard. It's pretty cool. So if you're gonna put this thing in a case with a glass side and show it off, that looks pretty cool. Our full test system is based around the Fractal Meshify 2 with a Fractal 860 watt ion power supply and our Fractal 280 millimeter cooler. And that's what I used for our launch video and our launch testing, along with the 7950X. Temperatures, thermals, even overclocked, even with the curve optimizer. The VRM power solution on this is basically overkill. I mean, I don't think more power is going to be more better when it comes to AM5 and overclocking. The curve optimizer and trying to get your CPU to do more with less power is probably where it's going to be. In terms of other connectivity and other peripherals, the motherboard's pretty good. It does have a single PCI Express 4.0x1 slot at the bottom. There is a physical switch that will let you configure that to PCI Express 3.0. The reason they do that is compatibility. If you've got an older peripheral, PCI Express 2 or 3, that's a single lane, it might not even handshake correctly at PCI Express 4.0. This motherboard gives you a physical switch to limit it to PCI Express 3.0, which I think is a fantastic feature. At the rear I/O, we have two USB 4 ports. That is basically PCI Express type interface. It's wired into the onboard GPU on the AM5. If you didn't know that AM5 has an onboard GPU, maybe watch my other video to check that out. Yeah, all four of the AM5 CPUs launching today that I did videos on and everything else, they've got onboard graphics. It's only two RDNA 2 compute units, but hey, you can get the job done. And that's what those outputs use at the rear of the motherboard. We've got one USB 3.2 Gen 2x2 port. That's a 20 gigabit USB implementation. We've got 9 USB 3.2 Gen 2 ports, one HDMI, one Wi-Fi module that is a Wi-Fi 6E solution, one Intel 2.5 gig NIC, 5 gold-plated audio jacks, optical SPDIF, a BIOS flashback button, clear CMOS. Now, another thing that AMD is doing different with the X670 chipset is they are providing hardware support for BIOS flashback. So every motherboard, even the least expensive motherboard, should theoretically have a BIOS flashback capability because no extra chips are added. This is still ASUS's special solution as far as I can tell, which is fine. It works well. It's tried and true. No problems there. But just be aware that X670 BIOS flashback, being able to flash your BIOS from a USB stick, is a feature at the hardware platform level with AM5. That is amazing! In terms of other USB support, that chipset solution from Intel for USB 4, that is the JHL 8540. So, sort of latest generation. We can't call it the bolt that's made out of thunder. We can't call it that because that's a trademark thing. But that's physically, it's PCIe over USB. So, and we also got that clear CMOS button at the rear I/O. Now, this motherboard will support up to DDR5 6400 with 128 gigs, although not both at the same time. I actually did try running 64 gigs in this with 4 matched G.Skill Trident Z. Where's my memory kit? Yes, these things. DDR5 6000, even with Expo kits, was not really achievable, but I could do 5200, which wasn't bad. I'll take it. I also tried the 64 gigabyte Corsair kit on this motherboard, which is not an Expo kit, it's a DOCP. However, when I loaded the DOCP profile, it failed to set the correct voltage on the memory for some reason. I ended up setting that manually, and then it was fine. Now that may be because I'm using the, the launch day BIOS, and there's almost certainly going to be a day one BIOS update. So if you get this motherboard, be sure to actually do your BIOS update, and that issue might be resolved. If it's not resolved, if you get a DDR5 kit and it's not an Expo kit and you have trouble using DOCP to load the profile, first check the voltage. It's probably the voltage. Then check the timings. You might need to increase the primary timings just 1 or 2 in order to get the system to boot. And then you should really do, MemTest 86 or something like that for a stability test just to make sure. DDR5, oh, it's got some teething issues. That's okay. ASUS has done a pretty good job being able to support the universe of everything here. Our front USB-C connector on this motherboard is something special. It's something to write home about. It is a 3.2 Gen 2x2, so 20 gigabit with power delivery up to 60 watts and quick charge 4. Hopefully your case's USB-C cables don't melt because 60 watts through the USB-C connection, goodness gracious, good job. That is long overdue. That is a long overdue feature. It is amazing. That is almost worth the price of admission alone for this motherboard. So I can plug my phone into my front panel and goodness gracious, look at that. It's charging at 60 watts. Very nice. We also have 6 gigabit per second SATA ports that are also connected through the chipset. For slower devices, it's not really going to matter. Now, a lot of people might criticize the daisy-chained X670 chipset. We've got a PCI Express 4 connection from the CPU to the first chipset, and then the second chipset connects to the other one. Part of the reason to do that is to avoid the need for redrivers. There's some redriving capability built into the chipset, and they're sort of arranged horizontally on the motherboard, and then they sort of split. One set goes one way, one set goes the other way. Mostly it's for low-speed peripherals. If you don't actually use the PCI Express 4.0 M.2 ports on this motherboard, that is never going to bottleneck. Even though you've daisy-chained to the chipset there, it's just never going to bottleneck. We've got the single 2.5 gigabit NIC on this motherboard. Even if it were rocking a 10 gigabit NIC, that's only 1 gigabyte per second. That link speed, that interface, is 8 gigabytes per second. It's not going to saturate. I know we're close to it. All the 6 gigabit per second SATA ports, plus all the other USB ports that are hanging off of the... Even if you were using every port simultaneously, you'd be hard-pressed to really saturate that PCI Express 4.0x4 link. The only thing that really will do it are those PCI Express 4.0x4 M.2s. But you can have 3 PCI Express 5 M.2s if you take 8 lanes away from your GPU and run with this. That's a little frustrating though, because this doesn't rock dual M.2, and it's going to make your GPU run a PCI Express 5 or 4 by 8. So bear that in mind if you use something in that second X16 slot, the second physical X16 slot. It's going to use the lanes to the CPU, but that also means that you're taking away lanes from your GPU. Just something to keep in mind, especially if you're rocking the highest end GPU. In terms of other features, fit and finish, everything else, this motherboard, like all AM5 motherboards, it will take a little while to boot up for the initial boot. Now don't worry, once the motherboard has trained with your memory, the boot time is not very long after that. It's just when I would switch memory kits or something like that, I could have been waiting 2 or 3 minutes, 4 minutes, 5 minutes, for it to detect all the memory. Most of the time, the longer wait times was only when I was using like 64 or 128 gigabytes of memory. But you know, your mileage may vary there. Give it some time. One thing that I think Asus could improve is that when it's doing the memory training, it doesn't show you anything, or at least it didn't for me on the Q code readout or anything else. I've certainly seen other motherboards give me some kind of an indicator that memory training is going on, and this one didn't do it. So it's a little unsettling for that first boot. But again, once it does the memory training, once you get your memory in there and it's all being detected and it's got it set up correctly, you get your Expo profile loaded or not, subsequent boot times are much quicker. Normal, you know, few seconds boot time. So just something to keep in mind if you build a system based around this. In case you're wondering about the IOMMU groups because you intend to pass devices down, it's a new platform, new chipset, new things going on, right? Yes and no. On our Hero, you know, we don't physically have a lot of PCIe slots. So that second X8 slot that runs to the CPU, I'm happy to report whatever you put in there is going to get at least one, maybe more IOMMU groups. I'm using a PLX bridge to connect 4 M.2 through only 8 PCI Express lanes. That's not bifurcation or anything the CPU support. It's a literal PCIe bridge, but it assigns every device on the other side of the bridge its own IOMMU entry, which is fantastic. Unfortunately, a lot of the onboard peripherals show up in IOMMU group 29, which will make, you know, you'll have to use the ACS patch, or you'll have to do something unsafe if you intend to pass through those devices. But there are some USB controllers on this motherboard that do actually show up as their own independent IOMMU group. So study the table carefully if PCIe pass through, and, you know, doing a multi GPU build is your idea of fun, because we get the iGPU and you get 2 slots to work with. So you could actually do something interesting here. And I see 3 USB controllers that each have their own IOMMU group. So there could be something interesting here. Other than that, this is the same, you know, very high level of build quality that I've come to expect from Asus. It was a very well put together motherboard. There are a lot of BIOS features that are unique to Asus. They've certainly poured a lot of their experience into this. There are features for curve optimizer and for automatically sort of trying to find the sweet spot of your CPU. For the BIOS version that I'm using, it was at least as good as Ryzen Master. Maybe Ryzen Master was just a little bit better for those kinds of, you know, sort of automatic features. But I found that I could do a little bit better than both of them. Just, you know, 10 minutes of fiddling around and 10 minutes of, you know, just sort of trying to dial it in. Check out the overclocking video that I did separately. If this is launch day, this is on Patreon and Floatplane. But, you know, check out the overclocking video that I did, the AM5 overclocking video, for some hints about AM5 overclocking. And like I say, this was testing with the 7950X CPU, 16 cores, running with 32 gigabytes of memory at DDR5 6000. I was seeing about 64 nanoseconds memory latency, some of the highest gaming performance that I did in any of my AM5 testing. Very solid motherboard, very solid platform, very neat launch from AMD. Congratulations Asus, congratulations AMD on your new processors. I'm Wendell, this is Level 1. This has been a quick look at the ROG Crosshair Extreme X670E Hero. Yeah, it's pretty interesting. Signing out, and you can find me in the Level 1 forums.